Okay. Today we start the unit 4 representation. In representation we have a topic of object oriented representation, object and frames, frame formalism, structure description, description language, meaning and entailment, computing entailment, then taxonomy and classification. Now we start the first topic in representation, that is object oriented representation. Object oriented representation in AI. Why we use object oriented representation in artificial intelligence? In artificial intelligence, we often need to be a real world knowledge in a way that machines wants to understand and reason with it. So far, it helps us to do effectively by a way to be a organized structure and reusability, inheritance, encapsulations, and better modeling of the real world. First of all, we see organized structures. In organized knowledge, we use an object that represents the real world entities and classes. This makes the system easier to understandable and manage. And reusability. Once the class is created, we reuse it to create many objects without representing any code or logic. That is reusability. Inheritance is nothing but we can create a subclasses. The inheritance properties from a parent class helps reduce redundancy. And encapsulation is doing each object wants to store its own data methods, keeping things self-contained and secure. This improves the modularity and data production. These are the things, that is a classes, attributes, methods, object, how, why we use a object oriented representation in AI. We saw that. Then the better modeling of the real world, it's like a mirror, how we think in the real world. And it about the objects and behaviors, which makes designing intelligent systems more natural and initiative. Let me see how object-oriented representations works in AI. It means objects are used to represent actual things in the real world, like peoples, robots, or machines. And each object have attributes and methods. Attributes is nothing but it is a data about the object, and methods is the actions that the object can perform. This is a method. For example, we take a robot can be an object. In this robot, attribute it be a battery level and position, speed, and methods move or pick up or charge battery. Just like in real life, we can say the robot is a position and moves forward. Like that only we can able to say. And next one is a classes defined categories. In classes defined categories, it is nothing but it is a blueprint or a template for creating some similar objects. It defines the common structure and behavior that all the objects, the type will be the one definition. For example, we take a vehicle. It can represent all types of vehicles. Class can define shared attributes and methods for all vehicles. Attributes is nothing but here attributes is speed, fuel type, number of wheels. These are the things attributes is considered in this method, and methods have start, stop, and accelerate. These are the things. In simple terms, we said objects are like a real thing with data and actions, but in classes are like a templates that helps us to create many similar objects easily. These are the things. Next we see object store attributes and methods. It means each object holds its own data, that is attribute, and behavior it is nothing but is a methods. It's just like a real world thing. For example, we take a person object can have attributes, that is a name, age, height, and methods like we want to speak, walk, run, etc. It's like a mini package of information and actions all in the one place. Here inheritance prompts reusability is nothing but we can create a new class based on an existing one and reuse its features. Only we reuse the features. This saves times and avoid repetition. For example, we take a car. It can inherit from a vehicle class. In vehicle we set speed, fuel capacity, start, stop. Car inherits these and can add more extra, that is air condition, music system, etc. It's like saying a car is a vehicle but with some extra features. This is the inheritance. And it moves to let me move to encapsulation. It means the object hide internal data and allow access only through a specific methods. This keeps data safe from accidental changes. For example, we take a bank account object has a private attribute and public method. Private attribute is nothing but is a balance, and public method it is a deposit amount. We cannot directly change the balance. You must use the method just like a real life. Here we tell objects keeps everything organized. Inheritance saves times and efforts. Encapsulation protects important information. These features make AI systems modular, efficient, and reliable when modeling real world situations.